Now we're here to tell you how this all happened.
For this experiment, we used 4 simple materials: a saturated solution of potassium iodide, dish soap, food coloring, and 30% hydrogen peroxide.
In this experiment, we used 30% hydrogen peroxide. This is much more corrosive than the store-bought 3% hydrogen peroxide that you use to clean daily cuts.
During the demo, it is important to wear goggles at all times. While dealing with 30% hydrogen peroxide, it is important to wear gloves as it burns skin on contact. While 30% hydrogen peroxide is very dangerous, our experiment allows for all chemicals left at the end to be washed down the drain.
The reason we were able to wash the hydrogen peroxide down the drain is because a decomposition reaction takes place in the experiment. A decomposition reaction is classified by one substance breaking down into 2 or more substances. In this case, the decomposition of hydrogen peroxide left us with H2O and pure oxygen.
Normally, decomposition reactions and many other reactions occur at a slower rate, but with the introduction of a catalyst, in this case potassium iodide, we were able to speed up the reaction by allowing the reaction to take a quicker route, lowering the activation energy. A catalyst is a substance that is neither consumed nor produced in a reaction. It is important to remember that while a catalyst allows for the reaction to take a different route, it does not affect the enthalpy or free energy released in the experiment.
There are 2 ways to classify a reaction, exothermic and endothermic. A reaction is classified as endothermic when the reaction absorbs heat from the environment. Examples of this are melting of ice and photosynthesis. A reaction is classified as exothermic when the reaction releases heat from the system. While exothermic reactions are most known for releasing heat, a reaction is also exothermic when light or sound is released. Common ways to show whether a reaction is exothermic is by placing heat on the product side of an equation and heat on the reactant side of an equation for an endothermic reaction. Our reaction is exothermic as when we hovered our hands over it, we could feel the heat being released. Sadly, even though it's called elephant's toothpaste, it's not actually what they use. This reaction is still very fun to watch and can be done at home with less dangerous amounts of hydrogen peroxide.
Thank you for watching. We hope you enjoyed our experiment and lesson.